Let's look at another SSA example. We'll still go through the steps of determining if this is an SSA triangle, and then we will go kind of through our flowchart to decide how to go about solving for the triangles that are possible, if they're possible. So first I see that I have two sides, so side, side, and then an angle, and this angle here goes with one of the sides because big C is across from the side little c. So this tells me that I have an SSA triangle, or SSA case I should say, and I know with SSAs that I could have 1, 2, or even 0 triangles possible. So I'm not quite sure I'm not quite sure what I have here. I need to do a little bit more investigating. So the next thing I see is that C equals 25 degrees is the given angle, and this is acute. Okay, so now I'm kind of down that part of the path. And then I see that it's the side that it goes with, which is C equals 1, that C is less than the other side that's provided. So that tells me that I'm really in this kind of ambiguous, muddy water, and I just don't know if I'm going to have 0, 1, or 2 triangles. And so what the flowchart says is go ahead and proceed with solving for the other angle that's a part of this pair. So what I mean by that is we have A equals 2, C equals 1, big C is 25 degrees. So go ahead and solve for this angle A using law of sines, and then we're going to make a decision about 0, 1, or 2 triangles after that. Okay, so I know then that sine of big A all over 2 is sine of C, which is 25 degrees, all over 1. In this case, I'm trying to get sine of A by itself. So multiplying both sides gives me sine of A equals 2 sine of 25 degrees. This is all over 1, but I know that I don't need to write that. And so now I'm going to look at, in terms of getting A kind of freed, right now it is inside the sine function. So right now it's the input. Then what is the output of that function? Well, the output is just whatever's on the other side here, okay? And so I need to use an inverse function to switch their input and output. So now I want this yellow piece to be the input, and I want the angle to be the output, right? The whole point is freeing that angle here. Okay, and so this will allow me to solve for A. I can go ahead and put that in Desmos. I'm going to go over to my function menu, put in sine inverse. Inside there, I'm going to want 2 times sine, and then inside there, 25 degrees. I'm going to close those parentheses, and I should be good to go. I get A. A is approximately 57.70 degrees, okay, or 7 degrees. And this is less than 90 degrees. Okay, so this is less than 90 degrees. And so what my chart tells me is this is going to give me 2 triangles. So I've got a lot of work to do. And so what I like to do when I have this situation is just kind of break it down. I'm going to have 2 triangles. So one is going to be A, B, C. And notice that I'm using the sub 1 because I'm going to have 2 triangles. And then over here, I'm going to have A sub 2, B sub 2, C sub 2, little a sub 2, little b sub 2, little c sub 2. Now some of these things will be the same, but I like keeping them totally separate because I know that I'm going to say this is describing one triangle and this is describing the other triangle. Okay, so let's look at the things that are the same. So little c, this is the given information. And what this is saying is, this given information is saying over here, this is saying find all the triangles that fit this criteria. And what we have found is that there are 2 triangles that fit this criteria. And both triangles have A equals 2. Both triangles have little c equals 1. And both triangles have their C angle being 25 degrees. Now what we found was that one of these triangles has an A value of 57.7 degrees. And so what I'm going to do is call that A sub 1, because we found that there are two triangles. Well, then I'm going to call that A sub 1, like that. And just to the 10th here is fine. Okay. So how do I find what my A2 is, right? Like, how do I kind of go over to this other piece and see what's going on there? Well, A2 is just going to be take 180 degrees and subtract A1. So in this case, A2 is 180 degrees minus 57.7, and we get 122.3 degrees. So this is going to be 122.3 degrees right there. So that's what this is right there. So now we have some other things to solve for. So I can go back over to my triangle number 1. Here's triangle number 2. I can go back over to my triangle number 1 and then go ahead and solve for that other angle. Well, this is kind of nice because I know that B1 is just going to be 180 minus the A and C measurements, because in a triangle, all of the three angles have to add up to 180 degrees. So this gives me a B1 of approximately 97.3 degrees. So that can go right there. So that's this guy here. Okay. And then why don't I go ahead and solve for B2 over here, just so I can kind of bounce them back and forth. So B2 is going to be 180 minus the 25 degrees for C and minus the 122.3 degrees we found for A sub 2. So over here for B2, we have, I guess this is still approximately, since some of these other ones we used were approximate, 32.7 degrees for B2, right there. And the last thing we need to solve for are our little b's, and we can do so with law of sines. So let's solve for little b1 to start with. I'm given this pair. Let's use the pair that I am actually given from the start, so less chance for error. Sine of 25 degrees all over 1 is equal to sine of 97.3 degrees all over, and we can just call that b sub 1. And now I just need to solve for b sub 1. So b sub 1 is going to give me sine of 97.3 all over sine of 25 degrees. Okay, and that gives me about 2.4. Okay, and then I can do the same thing for b sub 2 over here. So I still have sine of 25 degrees all over 1, and then that's going to give me sine of, now for my b's, 32.7 degrees all over b sub 2. So solving for b sub 2 gives me sine of 32.7 degrees all over sine of 25 degrees. And again, these can all just be put into Desmos. This I get about 1.3. So now what I've done is solved for all three sides and all three angles of the two triangles that are possible with the given criteria.